All right, so I think it's about time. Now that we're all awake to the fire alarm, I'm so grateful for that. At 8 a.m. Why would they even test that? Anyway, so I've graded some of your papers, some of the assignments, and I think generally. So first of all, if you're worried that I passed, that I not passed the assignment, as long as you submitted something, then you probably passed. I think I've graded like 30 of them, and I've failed like 3 people, something like that. And the reason I failed is because one of them didn't submit anything, the other one submitted A and C wrong, and that A, like 1A and 2A, that's all. And they were both wrong, so there was really nothing for me to grade. But yeah, this class, the emphasis on the mandatory assignments is not really to pass them. Everyone is gonna pass them. It's actually to learn stuff for it. Like realistically, I think at this point you guys know that if you came to like office hours and you asked me how to do this, me and Adam would more or less just help you solve it by the end of the hour. So obviously the emphasis is not really on passing these. The emphasis is going to be on the final exam. And that's why I'm going to more or less go through the problems here. I'm not doing it on my notebook since I'm going to be swapping pages. I want to show you how to do stuff, I guess, faster and more efficient. Some comments though. This sum sign has been extremely troublesome for more than 60% of you, at least from what I've graded. Some of you wanted to use this. Some of you didn't want to use it and forgot it along the way. And some of you actually knew it. I think I saw like 5 papers in which they would always they would carry the sum sign, but they would write above it like, oh, this is actually A1, X1, P1 plus X2 plus, etc. Just to remind themselves that it's a sum, which I actually appreciated. Like I appreciated that because in the end, it's better to write something correct than looking fancy with the sum sign. Problem 2D was a killer. I think, yeah, it was a killer. And don't feel bad. It almost killed me a little bit. I worked with one student at some point and we solved it. I think he worked more than I did, but it's okay. We solved it together. And yeah, and I think 1 F and G were again like killers because all you have to do is just use exactly what you worked up to that point. But let me show you. So I'll work here. I'll actually show you. Some of you wrote like an absurd amount of pages. Like I had, I think 48 pages and I had 59 pages, which is an absurd amount. And while I appreciate your work and I can tell you to those, I can tell those person, you 100% passed. It's important to be concise and know exactly what you need to do because you won't have that time in the exam. You won't have time to write 59 pages on this. If you were to ask me, I think what you solved here, this assignment should not take more than 2 hours in an exam setting. Okay, maybe 3 hours, something like that. Now, obviously it took a longer time for you right now because you're not that experienced, you haven't worked, it's new material, etc., etc. But I'll show you how we're doing. So I have around 1 hour and a half, something like that. I have to explain, so we're gonna go like, but I'm confident I can finish it, and I'll show you how. Okay. So my problem was. So let's put it here. What is this? Seminar plenary session. 3 mandatory assignment. Okay, so problem number 1, it started like maximize over. So this is one thing that I've asked. From now on, you should get like what you're maximizing over. So for example, you didn't have, but you're maximizing here over xi, okay? And you're maximizing sum from I to 1 to n of, I think it was ai log of xi. Correct me if I'm wrong, someone has the problems there, but I think this was it. And it was subject to sum of from I to 1 n of xi pi is equal to m. Right, I think this was your problem, the first one. Now, I should memorize it by now, I know. Okay, so then on point A, you're asked to solve the Lagrangian, okay? Here's how we go. We put the Lagrangian up, and we have sum from AI. I think all of you managed to set the Lagrangian, so that's a great sign. This doesn't really matter. Sure. One thing that I would advise is, well, if you're actually keen on using the sum, always write these two things, this and this, just so you know what sum it is. Now, for a short explanation, for those of you that are still confused, this writing just means a1 log of x1 plus a2 log of x2 plus dot 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 plus an log of xn. Now, and obviously this thing means x1 p1 plus x2 p2 plus dot 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 xn pn. Okay. Now, a disclaimer: I have absolutely no problem in you writing it like this. If you do not like the sum side, I'll show you one big mistake that I've seen in, I guess, almost 50% of the papers, and it's actually like a really big mistake because they completely messed up the solution. Okay, so I have this, and I'm going to take the derivative of this thing. So I'm going to have derivative of L with respect to, for example, x1. Okay, I could write it right up. I could write this thing right off the bat for xi, but I want you to understand first, when I'm writing for x1, in this sum over here, which is just this thing, I only have x1 in this term. Okay, so if I were to write the derivative, it would just be a1, 1 over x1, plus 0, 0, 0, 0, 0, etc. Okay, plus how many zeros? Okay, minus lambda. And I have x1 here as well. Only here, the others is 0, so it would be just lambda p1. This is equal to 0. Now, in this case, everything that I wrote here, the sum, is symmetric. So basically what I wrote here applies to x2, x3, xn, okay? So at that point, once you're convinced that it applies to all of them, I can write xi here, xai, xi, pi, and then I write somewhere here I equals 1 to n. So I know that this applies to all values of x1 to xn, because as you would see in the next couple of problems, it's not going to work out. You know, you're going to have to do from 2 to n. Let's get there. So you get this, and most of you solved it right. You get ai over xi is equal to lambda pi, and then you just get xi pi is equal to a over lambda, ai over lambda. And now here is the big mistake. You are told to replace this in the budget constraint. So sum of xi pi from I to n is equal to, and now this is equal to, you know, I'll just write it out like in case it's easier to see. Because this is a really big mistake, which is slightly worrisome, because he might actually give you something with sums, okay? And it would be a shame to just mess all you learned just because of a stupid sum. So the idea is now that this is just equal to a1 over lambda plus a2 over lambda, I hope it's clear why, plus an over lambda. Okay, and now this thing is just equal to sum of ai over lambda, I from 1 to n. And this is equal to, you know, your budget constraint was equal to n before, so it's still equal to n here. So at this point, you're free to leave it like this. The way I like to write it is, I notice that if I can just add them here, so this is just equal to sum of ai, I from 1 to n of lambda is equal to m, you know. So lambda is equal to sum of ai, I from 1 to n over m. Now, this does not mean the problem is over. Another really big mistake. A lot of you computed this, and sad for you, you computed it correctly, but then you did not replace it in the XI relationship, which is a really, really big mistake. The problem is asking you to, you're asked to solve the problem. You're not asked to compute lambda. Solving the problem means giving me x1, x2, xn. Okay? Really, really need to be clear on that because it's been a mistake that's been really prominent. And again, this is a mandatory assignment, which is more or less do some effort and you'll pass. On the exam though, it might actually cost you a lot. And when I mean a lot, I'm meaning I'm talking, I don't know, out of 10 points, you just lose 4 for nothing. You just lose 4 points. We're basically doing this. Lambda is equal to this. So I get AI over xi is equal to sum I1 m AI over m. So x times p I. So xi is equal to AI. I'm actually doing this wrong, so whatever. All right, let's I guess it's too early in the morning for me to write it out of the front. So I'll just write it like more steps, I guess. Okay. And now one important thing that might save you some things. Here, remember, this I here is for pi xi here. Now, this is a sum over I, which makes it confusing, and I've seen this notation. So one way to just simply change that is this is sum over j, okay? This is one thing that I would use. Make sense? Like just so you don't, so just so you remember that this AI here only applies to this. The reason being that when I write xi is equal to AI times m over sum of aj, j equals 1, n times pi. The reason I wrote this j, oh, what the fuck? I hate this. Okay. The reason I wrote j over here is really important because, again, a big mistake that happened here, some of you just simplified aj with ai and you got m over pi, which is completely wrong. Because remember, this thing over here is a1 plus a2 plus whatever plus an. Okay, this is just a fixed AI. Does it make sense? Okay, the difference. You can't simplify. This is a sum of all AIs. This is just a fixed AI. Okay, and this would be the answer. This would be point A. Point B, you're asked. Any questions on this? Okay. Point B. Tucker. Okay, you're given the condition x1 greater than or equal to 1. This actually went pretty smooth for a lot of the people. Idea being is that you put it with a minus and you get x1 small or equal to -1, which is fine. And then you roll the new Lagrangian, which is the same one as before. So it's sum of AI ln of xi I from 1 to n minus lambda 1. Okay. Again, I don't care about your notation. You can have lambda 1, lambda 2, lambda mu, a, b. I don't really care. The notation for this coefficients doesn't matter. Okay. It's whatever makes you comfortable. So lambda 1, and this is the budget constraint. Xi pi I from 1 to n minus n. And then I have minus a lambda 2. Okay. I just like using lambda 1, lambda 2. I've seen some people are used to mu. That's perfectly fine. Again, I don't care which it is, and it doesn't matter. And this is just minus x1 plus 1. Makes sense on the setup of the my new Lagrangian with the new constraint. And now a big mistake is some of you only wrote the complementary slackness condition. Tucker conditions include the derivative as well. So I'm gonna write here derivative with respect to L with derivative of x1. Again, why am I writing x1? Because it's different. It's not the same. I have an extra term here. So I'm going to get the same exact things as I got in part A for this, which is AI1xi minus lambda 1 P1 plus a lambda 2 is equal to 0. Okay? And then I notice that the derivative for everything else, so this is I from 2 to n, okay? Really important, is equal to AI1xi minus lambda I pi is equal to 0. These are the derivatives which are part of the contactor conditions. And now you have the complementary slackness or whatever. I don't even know exactly how it's called, but I think that's how it's called. Anyway, and this, again, the direction of implication is not from lambda 2 to x1. It's from x1 to lambda 2. What do I mean by this? I write if x1 is equal to 1, then lambda 2 is greater or equal to 0. If x1 is greater than 1, okay, if you write whatever, minus whatever. If it's strict, then lambda 2 is 0. First observation is this is greater or equal to 0. It's not strict. Second observation is the fact that I don't want to see the other way around. Like I don't want to see lambda 2 is greater or equal to 0 implies x1 is equal to 1. No, I don't want to see this. Okay? It's not okay. The complementary slackness for the contactor are this way. You start from the inequality and then you move to lambda. Okay? Make sense? The reason being that if you started like this, if lambda 2 is 0, then you can be in both cases. That is the problem. If lambda 2 is 0, you can have x1 is equal to 1, and you can also have x1 smaller than 1, with a minus, whatever. So this is why I do not like the x2 being equal to 0, and then you look for x1. No, you look at x1 and you give me the lambda conditions. Okay. I see some of you use the phrasing with that lambda 2 is greater or equal to 0, and lambda 2 is 0 if it's strict. That is fine. But remember that lambda 2 can be 0 even if x1 is equal to 1. Okay? That is something that you have to remember. I don't think you received the problem yet, but you have to remember that. Okay, now, everyone agree with what I did here? Nothing special, right? No, nothing out of the ordinary. Now, point C. Again, really big mistake that I've seen is most of you just, okay, let me write the pages so I don't confuse myself. This is 1. This is 2. Okay. So you can't replace x1 here. Do not replace in the Lagrangian. You have received really simple exercises in which it somehow worked out. And I think this is an overlook on the professor's side in the sense that he hasn't given you a problem that just destroys the people that replace in the Lagrangian. This is not correct replacing in the Lagrangian. And again, yeah, definitely not. The way I would solve this, a lot of you basically just said, okay, I'm going to discard this thing. I don't care about this relationship anymore, about x1. And I'm just going to look at from 2 to n. And then you got the correct solution, which is, I guess, somewhat fine. Okay, I would have given you points on the exam for that. But the way to look at it, the cleanest way in which I don't have to write a single line, and I'm just going to give the solution, is my problem initially was this: maximize over x1, x2, xn. I'm maximizing sum from I equals 1 to n of ai log of xi, subject to I'm lacking. Okay, sum to 1 to n, kind of like brain physics, right? Okay, is equal to n. Okay, this is your initial problem. Now I tell you x1 is equal to 1. At this point, you should know this. I am not maximizing over n variables anymore. I am maximizing over n minus 1 variables. Does that claim make sense? I can't have x1 vary anymore. This maximization problem is telling you, give me x1, x2, xn, such that this thing is the biggest it can be. Okay? Now, if I tell you x1 is equal to 1, this means that your problem becomes just maximizing over x2, x3, xn of sum from I equals 2 to n of ai log of xi. Does it make sense what I'm saying right here? I can't touch x1 anymore. I don't care about x1 anymore. There's nothing I can do to it. If I tell you, maximize your utility at home, buy apples, oranges, and grapes, and then I change my mind and I say, you're going to buy 1 apple. You don't have a decision to make anymore about apples, okay? So you don't care about it. You can just take it away. So that is what I'm doing right now. I'm not maximizing over x1, x2, xn. I'm just maximizing x2, x3, xn. Okay, x1 is out of the equation. What's my constraint? Subject to, this is something that you all did correct. Remember, this is x1 p1 plus x2 p2 plus xn pn. So this is just x1 p1 plus sum from I equals 2 to n ai of xi pi is equal to m. So subject to I equals to 2 to n. Also, I'm sorry, I don't know what's up with my course. Okay, this is 1. Of course, so this is just m minus pi. Doesn't make sense what I did here. Okay, I just rewrote the problem with respect to the other. Yeah, this is supposed to be a minus. Oh, sorry about it. Yeah, of course. Yeah, this P1, of course. Yeah, of course. Okay, so I just rewrote my problem in terms of the remaining n minus 1 variables. And now what do you see? I'm seeing that this problem that I have to solve right now is just exactly the same problem I solved in A. Okay? It's exactly the same problem I solved in A, just with a different budget constraint over here. Do you guys agree with that claim? It's exactly the same one. Look at it. This is the one in A, max over xi, whatever, sum of ai subject to this. And then the second, and now I have to solve max of the same thing, just one less variable, subject to this. It's exactly the same problem. So at this point, all I have to do is just say, same solution as an A. Okay, so realistically, if you just wrote problem just becomes this, and then same solution as an A, right? X1 is equal to 1, but xi is equal to, I'm just going to copy the solution from A, which is ai times n minus p1, sum of, again, careful here, j is equal to 2 to n aj times pi. This is I to n. Make sense? What I did here? I just noticed that it's the same exact problem, so I don't need to solve it anymore. You're basically just doing the same thing over and over again. That thing works smarter, not harder kind of thing. This is exactly one of it. Okay. Any questions on this? You can ask me in the break if you want to ask right now. Although it might be helpful for everyone. Okay. So this is my solution. Now in D, what does it mean if I have x1 greater than 1? I am in the second case of the Kahn-Tucker, this one. So I get lambda 2 is equal to 0. So then I look at my derivative with respect to x1, and I get a 1 over x1 minus lambda 1 p1 plus lambda 2 is equal to 0. This lambda 2 goes away. Okay, it's just 0. Again, do not replace in the Lagrangian. Replace in the derivative. Okay, really, really important. Because afterwards, then after that, you might just ask, it doesn't make sense. How do I do it? Just replace in the Lagrangian. Okay. And again, I see this thing And I'm like, this looks oddly familiar to what I got in point A, right? It just looks exactly the same with what I got in point A. It's this thing. It's exactly the same because the other condition was dl dxi, I from 2 to n is just ai 1 over xi minus lambda I pi is equal to 0. So basically, I'm just getting the exact same solutions as in A. Okay? The difference is that when I solved B, I couldn't apply A because I had this annoying lambda 2. You see, like the equations are the same. I couldn't apply what I did in point A because I had this annoying lambda 2. Now, in this case D, I know lambda 2 is 0. So I actually have the exact same conditions that I got in point A. So I can just write again. Point A gives me the solutions xi is equal to ai m minus pi. Xi is equal to ai. I can't even copy right now. M sum I equals 1 to n. AI aj. I said I used aj, so let's keep it times pi. Make sense? I have the same exact conditions. No need to solve it again. Okay, it's the same thing. Now, again, because here, like some people replace their P1, replace their thing in the Lagrangian, and then they said P1 is some sort of a constant because it doesn't appear there. I don't really know exactly what the logic is, but they got the wrong result. Okay, this is why I only replace the derivative. Again. So this is my solution for this problem. Cool. Let's see what's next. Next is point E. I think point E was show that it has a maximum or something like that. Wasn't that point E? Hey, any ideas? I don't want to log in right now and ruin the whole thing. But I think that's what point E said. Right, it was show that it has a maximum and then hint some of, sorry? Yeah. So in point E, it asked you sufficient conditions for a max. Okay? Sufficient conditions for a max. And then they give you sum of concave functions is concave. Okay? Oh, sorry. Okay, so necessary. Oh, yeah. So necessary is what needs to happen. But the idea is that if those conditions happen, if the necessary conditions happen, it doesn't automatically mean, okay, it's too abstract. Give me a second to think of an example. Okay, I have one. I have a very simple example. Sufficient, okay? I want to see if f of x is greater than 0 for all x. Okay? This is what I want to see. A sufficient condition would be f of x is equal to x squared, or greater or equal to 0, whatever. Okay, this is a sufficient condition. If you give me this, then automatically I can tell you that f of x is greater or equal to 0 for all of them. Okay, this implies f of x is greater or equal than greater or equal to 0 for all x. Obvious. Now this is sufficient. It's maybe a very strong sufficient condition, but it's a sufficient condition. Okay. Now necessary. If I want this to happen, then it means in particular f of 2 is greater or equal to 0. This is necessary to happen. Okay, if I want this function to be greater or equal to 0, it has to happen. F of 2 has to be greater or equal to 0. But this does not imply that f of x is greater or equal to 0 for all x. Does it make sense? So necessary is something that's going to give you it's something that is going to happen in the case that f of x is greater or equal to 0. If f of x is greater or equal to 0 for all x, then in particular f of 2 is greater or equal to 0. Okay, this is a necessary condition. for this to hold, but it's not sufficient for me to claim that it's greater or equal to 0 for all x. On the other hand, if I had f of x is equal to x squared, then it is sufficient condition for me to claim that f of x is greater or equal to 0 for all x. I would say, so I would say sufficient is something that will give you the conclusion. Like if that happens, it will give you the conclusion that you want. Necessary is something that happens in the conclusion, but it's not strong enough to give you the result. Okay. Just think of this example, I guess, a little bit more. So as you can see, in the sufficient condition, I can draw the conclusion that f of x is greater or equal for all 0. In the necessary one, I can draw the conclusion. I cannot draw the conclusion for that. Okay. Now, I think the example is, I mean, it's as simple as I can make it. I don't know, but this is a sufficient, not necessary condition. Is it necessary for f of x to be in particular equal to x squared, just so I have f of x greater or equal for all x? No, not really. I could have f of x is equal to 2 for all x's, and that would be another condition. Yeah. Let me maybe just use some values. Okay. If I say f of x is equal to 2 for all values, and then f of 2 is equal to 2. Okay. This is for all x. Maybe now you're going to see the difference, I guess, a little bit better. In the sense that if I tell you that f of x is equal to 2 for all x's, then it is a sufficient enough argument for you guys to claim that f of x is greater or equal to 0 for all x. Okay? Because 2 is greater or equal to 0. But if I only tell you that f of 2 is equal to 2, it is I mean, I need to use 0 here. Yeah, I need to use whatever. Replace 2 here, whatever. I need to use 0 here because it's not as sufficient anymore. It's not necessary. Okay, it's not necessary in that case. If f of 2 is greater than 0, if I only tell you that f of 2 is greater than 0, then it does not mean that the function is positive for all values of x. It just means it's positive for 2, which is necessary. So it will happen in this case, but it's not sufficient to show it. Okay, I'll just let it sink, I guess, a little bit. But if I have a better example, I'll think about it. Okay, but this is, I guess, the easiest I could do. I'm sorry. Okay, anyway, so sufficient conditions for a max. I love the idea that some of you try to use the ABC rule, the whatever. The thing is that you were overmatched to start with. Like you didn't, unless you completely got the hint, you didn't really have a chance to solve it. The way you solve multi-variable things is with the Hessian, which is something that you guys don't know. So the way the professor thought to cheat his way around it was note that I can, cheat. Notice that I have my this sum, ln of xi, I from 1 to n. Notice that I can split these functions, okay? I can just write it as a1 log of x1 plus a2 log of x2 plus an log of xn. Okay, so now the idea is that if I just write this is f1 of x1 plus f2 of x2 plus fn of xn, okay? I just define these functions. I just define this, just a way of writing. And in particular, what the professor says is that if each of these functions is concave, then the whole thing is concave. Okay? Because, and the idea is that this, since I had this sum, I could just separate it into small bits. Okay? I think this is definitely not how I would solve it in a Hessian mode, and this is definitely not how you're going to solve it if you do math 3 or whatever. I know you use some of you use the 8BC rule, quite inventively, I might add. So that's really good. You know that, which is good to keep in mind. But it's not how you're more or less supposed to do this. The idea is this thing, that I can separate this into these functions and write them like f1, x1, x2, x2, fn, xn. And the idea is that if this is concave, this is concave, and this is concave, then when I add all of them up, I still get concave. Okay, that's the idea of it. And now basically, we can just take a derivative. So I'm going to take a derivative of ai log of xi with respect to xi, and I get ai 1 over xi. And if I take the second derivative, I just get minus ai 1 over xi squared, which is smaller than 0. So it's concave. Okay. This is the way he intended to solve it. But again, if you did miss this one, don't stress it too much, because again, it is something that you're not really well equipped for, if it makes sense. Okay. But you can, if you want, you can remember that a sum of concave functions is concave and the sum of convex functions is convex, and et cetera, et cetera. Okay. So that one can be a takeaway if you want. But don't stress about this too much. Now, point F and G just basically destroyed people. And I'm partially confused why, in the sense that I think it's just the simplest, smash and grab problem I've seen, in the sense that you've done I've seen people do all the work perfectly, and then F and G, they just write question mark and they have no idea how to start. So let me shed some light here. So I think it's A1 equals A2 equals A3 is equal to 1. I think P1 is equal to 3. P2 is equal to 2. P3 is equal to 1. And M is 12. Something like that. I think so. Okay.
And 3.
Yeah. I mean, since I had 3 of them. Yeah. All right. So this is your thing. And now all you had to do here is just replace and use what you computed. So what I mean here is, okay, just my case, x1 greater than 1, first case. This means solutions are, it's right here. That means I have x1 is equal to a1 times, I'll just replace it. Fine, I will not replace it. Sum of aj from j equals 1 to 3 of p1, okay, which is just equal to, let's not prolong it more than it has. So it's 3 times 3, this is 12 over 9. X2 is equal to, I'm just going to write it off top, straightforward. I hope that's not a problem. 3 times 2, this is 12 over 6. Then I have x3 is equal to, I don't know why I start so fast and then I just stop. Okay. Cool. Now, some of you check the budget constraint. That's respectable. I can admire that. Not particularly necessary, but yeah, you can check it. We can check it if you guys want, but I don't think I think it's automatically what's it called? So it satisfies itself. I don't need to check for it. Okay. But yeah, this is it. And then what you do, you get x1 is equal to 1, which is the other case. Okay. You're basically just building your whole solution on the Contact condition. Okay. You're basically just taking everything you've learned and you're building your solution on the Contact. This I'm using point D. X1 is equal to 1. I'm going to use point C right now. And I'm going to get x1 is equal to 1. x2 is equal to, what is my point? I'm gonna know 2, 3, 4. Okay. Okay. So I'm gonna get x2 is equal to this is a big mistake over here. So your formula is a2 m minus p1 over sum j equals 2 and here's the thing right here. This is why some of you didn't get the budget constraint satisfied or etc. This is from j equals 2 to n. It's not from j equals 1 to n. Okay, look at my formula. It's j equals 2 to n. Small mistake, but it did cost some people. Again, if it happened on the exam, in this case, in this particular case, we probably only lose like maybe 1 out of 10 points or something like that. So I wouldn't really care that much about it. But obviously, if you can get some 3 points, why mess it up on the last 10 meters? Okay. So I just get 1 times 9 over 2 times 2. So that's 9 over 4. X is equal to 3. That's fine. Or so please. Okay. This is A3 m minus P1. Again, this is point C. I'm just copying the solutions for point C. You don't need to resolve it. You don't just use what I've done. Okay. J equals 2 to n. 8. Why am I writing everything again? We have no idea. We're just writing it because we can. Okay, and we get, again, I'm adding from 2 to n, which is 2 to 3. So most of you, I mean, not most of you, but some of you basically added from 1 to 3, and they got this sum as being equal to 3, when in reality it's just 2. Okay, because you're adding the other two numbers. You're not adding x1. You're adding a2 and a3. This is a2 plus a3. Okay, you don't have an a1. This is why some of you got some wrong answers here. Again, I wouldn't care that much, but yeah. 2 times 1. This is 9 over 2. Yeah. If you just did the math, if you just added everything here, I'm pretty sure you would get the budget constraint. Yeah. Yeah. I think this satisfies the budget constraint as well. So the way you need to check it, the way you check which solution is good, okay? So right now, in this case, I have 2 solutions. I have this case solution and this case solution. The ugliest part of this problem, which I personally hate, is you have to plug in these values in your function and see which one gives you a bigger value. So what do I mean by this? In case 1, I have sum of, just write out a1 log of x1 plus a2 log of x2 plus a3 log of x3. And this is equal to log of 12 over 9 plus log of 12 over 6 plus log of 12 over 3. Sure, it makes sense. Okay. And then this is how you solve this kind of problems. You go on Google and you use the computer given. Yeah, I guess I could do some tricks, but again, I don't care that much about it. Let's see. This, I don't know. This is literally just plug it in. I'm assuming you are not going to get something like this on the exam, because if you ask me, the difference was really small. I think one of the correct answers was like 231, and the other was like 226 or something. So I don't know the correct answers. I haven't bothered to compute them, but I assure you, you wouldn't get something like this on the exam, like where you actually need a calculator, when the difference is that small. Okay. So yeah, this is equal to some number, and then the other one, I could use Google if you want, but we'd rather not. I think it's boring. Okay, and in case 2, I have again a1 log of x1 plus a2 log of x2 plus a3 log of x3, and this would be equal to log of 1, which is 0, plus log of 9 over 4 plus log of 9/2. Can I maybe compute this and see which one is bigger? Yeah, I don't know really. I would plug in the calculator here. Okay, and you see which one is bigger here. I think this one is bigger. Mathematically, I'm estimating that this one is bigger, but I might be wrong. Again, let's just work under the assumption that the first one is the good one. Okay, we work under that assumption. So is equal to some number. I don't know. Let's put them like again, not 100% on the numbers. Okay, I think this is like 2.3 something. I don't know, and this is like 2.2 something. Again, not 100%. So you get that case 1 is bigger than case 2. So the maximum solution is 1. And is the constraint binding? Well, case 1 was x1 greater than 1. So is the constraint binding? No, no binding. Everyone agree? Who added? Okay, now in point G, you surprise, you do exactly the same thing. Okay, in point G, I think M becomes 6. So you do case 1, and you just say, okay, x1 is greater than 1. I use D, and I get x1. I'm just copying the formula. I'm just getting 1 times 6 over 3 times 3, which is 6 over 9. And here you can actually stop at this point and just say, I'm saying x1 is greater than 1, but I get a value x1 smaller than 1. So it means wrong case. I don't need to work anymore. If the solution they give me is smaller than 1, and I'm working on the assumption that x1 is greater than 1, I will see contradiction. Okay, wrong case, / contradiction. This is similar to a lot of problems that you did. Remember the ones where you were in the strict case, you get lambda equal to 0 and you get something weird that didn't make sense. This is kind of similar here. Okay, I just discard this. I don't care about it anymore. It's not, because it's not okay. So then I only have left case 2, which is x1 is equal to 1. So it means that using point C that I get x1 is equal to 1, x2 is equal to, I'm just copying off my other page, so I'm not doing anything smart if that's what you guys are scared of. 1 times 3 over 4, this is 3 over 4, and x3 is 1 times 3, 2 over 1, this is 3 over 2. Okay, and obviously this is the maximal bundle where, well, it's the only one. So case 2 is the max. Is the constraint binding? Or case 2 corresponds to x1 is equal to 1, so yes, binding. Okay. Yeah, I guess that's problem number 1. Any comments, opinions? Five, 6. Okay, and I guess I wrote a lot of pages, but I did write absurdly big. So anyway, I think we're on time. So feel free to take a 10-minute break. If you have any questions, let me know. Realistically, I think that you just needed to observe that you can use what you've worked up to that point. You don't need to redo it every time. Okay. So yeah, just take a break and we'll do problem number 2. Okay, let's move to problem number 2, and in particular problem number 2D, which everyone is so excited to see. So, problem number 2. Point A. Wait, write the function. F of xy is equal to, might need some help here, 5xy minus xaya. Is there something else? Thanks. Minus 4. Yeah, and you had a greater than 1, I think, something like that. Okay, cool. The first one asks you to compute partial derivatives, etc., etc. So let's just do it. Derivative of f with respect to x is just equal to, here I just have 5y minus derivative of an exponent, pretty clean. Okay, with respect to y equals to 5x minus a, oh, let's write it in the order, it's nicer that way, a minus 1, with respect to f squared, x squared, it's just equal to, this becomes 0, so I get 0, write it, a, again another derivative, a minus 1, x a minus 2, y a, derivative of f x squared, that's what should be here, is equal to z of y squared, this is equal to 0, minus xa times a minus 1, y a minus 2. And now let's just do the derivative of x and y. I don't even know if it's necessary. I don't remember if the problem asked you to do it, but sure. F derivative of x derivative of y is equal to, let's just take a derivative of x here. Remember, this is equal, it doesn't matter which order you do the derivatives, okay? This is equal to this, right? It doesn't matter how you take the derivative, they're the same. Okay, and obviously everyone knew that. So this is just 5 minus a x a minus 1, a y a minus 1. Looks right, looks okay. Cool, I'm happy. So these are your partial derivatives. We're done. Point B. This, I'm happy to say, I think almost everyone got right. Point B, now, on point B, I made one comment, I think, on 99% of the papers, which is I need more explanation, and I will elaborate on what explanation I was looking for right now. All right, so you all did the correct, okay, you all did the correct thing, which you said, okay, d of f is equal to d of x is equal to 0, d of f is equal to d of y is equal to 0. So you just made it equal to 0, and you get 5y minus a x a minus 1, y a is equal to 0, and then you get 5x minus xa times a times y a minus 1 is equal to 0. Perfect, I agree. And then most of you just said, hey, let's just take divide by y, divide by x, and you get the system of equations. If you want to write like this, 5 is equal to a x a minus 1, y a minus 1. 5 is equal to a x a minus 1, y a minus 1. Everyone understand? I understand what I'm doing here, right? I'm not. I hope there's no confusion what I'm doing here. Okay, cool. And then you get just xy from here is just equal to 5a to the 1a minus 1, something like that, I think. Yeah, I think that's correct. All right, you just get it from here, and then you left, and then most of you just left it like this, okay? Which is the correct answer. Like once you're here, you're done. I just wanted. Are you guys confused with what I got here? I mean, it's just I can write another step, I guess. It's 5a. This is just equal. 5 is equal to a times x, y, everything to a minus 1. So I just move to the other side and I get 5. Let's go on the other side. I just get 5 over a is equal to xy to the a minus 1. So xy is equal to 5a 1a minus 1. Or square root of order this, I don't know. Okay, so you've got this answer. And now most of you just left it like this. This is the correct answer, no denying. But why are you leaving it like this? Or, you know, you wrote something like x is equal to 5a 1 over a minus 1 times 1 over y. And you left it like this and said this is the solution. I wanted to know, why is this the solution? Why can't you go further if it makes sense? Okay, because remember, if you would have done something in the Lagrangian like this, if you would have written this relationship in a normal Lagrangian, you wouldn't have solved the problem. Remember, you can't give a solution of x in terms of y, unless special cases. This is one of the special cases. So I was looking here, I said, I need more explanation. Here in B or in C, both apply. The explanation I'm looking for is one, I've actually seen this, which is partially fair. One explanation is that I notice I have two variables, right? This is x and y, and you effectively only have one equation. They're the same equation. One equation. So this means you have an order of freedom, or you can write it as that. So this allows you to just write it, to just look at the product. In case you didn't know this, you need the same number of equations as the number of variables in order to solve the system. Okay, so you can solve 2 with 2, 3 with 3, but 2 with 1, you're going to have something like this, where you don't get both of them defined. This is one argument that I've seen in some papers. I was quite surprised by it, and it's fine. But the argument I was looking for, which is more natural, if you ask, more natural if you ask me, is to just look at the function for a second. Okay? This is one advice I have. If you get it on the exam, don't just immediately panic. You have 4 hours. Just spend 1 minute, look at the function, and think about it. Can I get something out of it? Does it say something to me? Is it something weird with it? Okay. And what I was looking for is something like this: f of xy is equal to 5xy. And remember, I had x to the power of a, y to the power of a. So I just get x, y to the power of a minus 4. So now you can look at this function. And the idea is that f of 110 is equal to f of 25. Makes sense. Like if you just replace them, you notice from this that the value of the function is given only by the product of x and y. This function does not depend particularly on x and on each of them. It's just on their product. So let's replace it. Like let me show you. F of 1 and 10. This is 1 times 10 is equal to 2 times 5. So let's just replace it. 5 times 1 times 10 minus 1 times 10 to the power of a minus 4 is equal to 5 times 2 times 5 time minus 2 times 5 to the power of a minus 4. So if you just write it out, this is 5 times 10 minus 10 to the a minus 4 is equal to 5 times 10 minus 10 to the a minus 4. Okay, so the idea is that this function is somewhat weird, and although it depends on two variables, you only care about the product. Okay, so that is the reason why your solution, why your optimal points, your maximum points, only care about the product. Okay, that is the argument I was looking for, and that is the argument you're supposed to give either here or in C. Okay, so again, I think this problem is relatively short, so I think I'll just repeat the argument. The idea is that you have computed this point, which is correct, but the argument why you stop here, why you can't give more than this, why you can't give me x is equal to 2a or something like that, and you just have to relate it to y, is because the function effectively only depends on the product. Okay, as long as the product is equal, the functions, as long as you're given a product, it doesn't matter what x and y you have. You're going to get the same value. So at that point, when we're trying to maximize this function, or the critical point, the result is only going to depend on the product of x and y. It's not going to depend on x or y. Okay, just their product. And that is why this, if you notice this basically, and the way I would answer it formally is, we can see that the function only depends on the product of x and y. Therefore, it is normal / expected, I don't know, however, depending, for the result to look like this. xy is equal to 5a over 1 minus a minus 1. Make sense? Does my claim make sense? Like what I'm saying here? Okay. Now, yeah, hopefully that works out. Now, for point 3, what is this? Okay, I guess I played something. For point C, you're asked to show x, y, k are level curves, and this is where some of you actually really impressed because you more or less did it some sort of utility, which is a great observation. You basically said, if this is x, this is y, then you have these indifference curves, and let's say xy is equal to k1, xy is equal to k2, these indifference curves, which I like it. I think this argument makes sense. It's good. Okay. But what I didn't want you to do here, I didn't want you to just do this, is basically just replace xy with k and say, okay, f of k is equal to 5k minus ka minus 4. Take a derivative, etc. F prime of k, I don't know, it's 5 minus a, ka minus 1 is equal to 0. So k has the same result. Okay. This mathematical thing is not really enough. I need you to show me why this function looks like this, why this function is on indifference curves. Okay. Why only the product matters, which is why I said I think you needed this argument that I wrote with the product being the only thing that matters, either in B or C. For me, it didn't matter where you wrote it. I would still give you maximum points for both of them, but just write it somewhere. Okay. Yeah. So that's why, that is why he says that you are on hyperbola or whatever. You can replace it with indifference curve or etc. Because he's basically saying that your function only depends on xy. That value k is going to generate all your results. What he's saying is that this function, f of xy and just f of k, can get the same values, which is not normal because you would expect something that has 2 variables to get more values than something that has only 1 variable. Okay, but in this case, it doesn't apply. So that's why he says it's on those things. Yeah. In case you were, relax. Like I think I said good, even if you just wrote this. But sometimes I was expecting another argument, which is, in case you're wondering, this is what I was looking for. Okay. And I hope it makes sense why you needed this, because in a normal Lagrangian problem, if you left x like this, you would lose points. But in this case, it just makes sense to leave it like that. That is my argument that I'm making here. Try to make it at least. Okay. Any questions here? Okay. Now let's look at, I would say, the hardest problem of them all. So if you solve this by yourself, or if you thought of it by yourself, it's an extremely good sign. So it's here, it's asking you, it's giving f of z, which is 5z minus z to a minus c, something like that, I think. And he's asking you conditions for a and c for 0, 1, 2 solutions. Okay, this is I think the hardest problem, and yeah. Now, how do you start it? It's hard. I think he gives you some sort of a direction by suggesting you to look at concave, convex thing. Okay, so let's see. Is this function concave? Is it convex? So if I take the derivative, I just get 5 minus a za minus 1. And if I take another derivative, I get minus a minus 1 z to the a minus 2. Okay? Now, a is greater than 1. So this function, this is greater than 0, this is greater than 0, this is definitely greater than 0, so this is smaller than 1. Oh, smaller than 0. Everyone follow on this? Okay. So it's concave. Really important, because this is the one thing we're going to build on. Now, I want you to think from a graphical standpoint, only from a graphical standpoint. What does it mean that f of some z star is equal to 0 from a graphical point of view? Where is this point, z star 0? Where is it on the graph? Exactly, right? Any point, like if this is z star, has to be here, okay? Because this is my z, this is my f of z. If f of z star is equal to 0, then it has to be on the OX axis, because, you know, 0 is here. Yeah, I think I'm not going to dive too much into this, because I think it just makes sense. Okay. Now, let's combine the concave part. Let's plug it in here. How does the concave function look like? Okay, that's a concave function. Now, let's look at the concave function and my OX. Let me draw it. I hate that page. Okay, let's try a new one. Something like that. Okay. How can a concave function hit my OX axis? Okay, because if it hits my OX axis, I have a solution. So, for example, if my concave function looks like this, am I going to get any solutions in this case? No. Why? Because this graph is not going to touch my z-axis. Okay, so in this case, I can say no solutions. What if it looks like this? Just touches it once. This is supposed to be a point only. Okay. How many solutions do I have? Well, it's touched, exactly, touched it in one point, so it has one solution. And then there's obviously another case, which is like this, where I get two touches, so this is two solutions. Everyone agree with these cases? Okay, now, in which case are we? That is, I guess, the last step you need to take in order to solve the problem. How can you tell in which of these cases you are? Okay, let's see. And the way you will look at it, you just look at the pointer from here. Just look at the maximum. It's concave, so it has a maximum. Okay, so I'm just going to look at this point, which is the maximum. max point. Okay, and I'm gonna look how that max point looks with respect to 0, which is basically the z axis. Does my logic make sense? So I'm claiming that this. Can I zoom even further? No. Well, so I'm claiming that if f of z max is smaller than 0, I'm in this case. If this is z, if this is z max, then this is f of z max. And this is z max 1. I don't know how to call it, z max, okay? If f of z max is smaller than 0, my claim is that I'm in this case. Now, for the second one, if f of z max is equal to 0, my claim is that I'm here. I'm in this case. And lastly, if this is f of z max over here, this case is just f of z max greater than 0. Does my spread of cases make sense to you guys? Okay. So I use the fact that it's concave, and I just draw the shapes, and I use the fact that if f of z star has a solution, then it means it has to touch the OX axis. So what I did is I just basically combined that. Okay, I just tried to draw this concave function in all possible ways I can think of, and these are the only 3 cases that pop to mind. Okay. So now, what is my z max? What is this z max value? This z max value is you solve for it in point C. It's the same function. It's that z max is just equal to 5 over a 1 a minus 1. That was a critical point, right? It's a critical point in a concave function, so it's the maximum. Remember when you were asked here in point C, solve for the critical point, and you got this k is equal to this thing. If it's a critical point in a concave setting, it is the maximum. Okay. So this f of z max, which is this thing, is going to give me the maximum value of f. So all that you had to do left, or all you had left to do, if we were to speak English, is just to look at the cases. Case 1, where I don't know, just 5 times 5a, you just plug it in, 1a minus 1 minus 5 over a 1a minus 1 minus c is smaller than 0. This is my case 1. Obviously, this is f of z max. I don't know how to write it. It both works. But again, case 2, f of z max is equal to 0. You just plug it in. And 3, f of z max is greater than 0. And for each of these cases, you're just going to get a condition on a and c out of here. I don't really care that much about the condition. I'm more interested in the logic that got us there. Okay. Realistically, I think if you just made like a small mistake here and got me the wrong equation, I would still give the maximum point for this. Because obviously, it is not trivial, okay? This problem is definitely not trivial for me to just look, oh, he messed a minus here, I'm going to subtract 2 points. Obviously not. Okay. But did this killer problem make sense? So my steps that I took were, I checked that the function is concave, first step. And then I asked myself, what does it mean for it to have a solution? Have a z star that's 0. And it means that I have to have a point on the graph of the function on the OX axis or the OZ axis or whatever you want to call it. And then I just drew a little bit. And I tried to see what are the cases that a concave function touches the OZ axis. And these are the 3 cases where it touches it. And they correspond to these cases that I wrote over here. And once you're here, all that's left is just plug in the values and get me some relationship. Okay. Realistically, even if you wrote this is I would have probably given like even this, to be honest, I would probably give it full point. Okay. I don't need to see do some fancy computation. Nobody cares about that. Okay. Any questions on this? Or are we completely lost that there's no way of coming back home kind of thing at this point? Okay, so we're completely lost. Good. So let's move on to the next one. Just like I planned. I'm gonna need some help here because I don't really remember it. It's yeah, I'm definitely need some help here. I think you had to do a max of P1X. Okay, whatever. A minimum of, can someone just say it or should I just look it up? Oh yeah. I think I remember QI subject to XY to the 5XY. Is it just that? XA, YA minus 4 is equal to where A is equal to is equal to 0?
No, it's equal to 4. So yeah, equal to 0.
Yeah. Okay, equal to 4. Okay. After remembering the problem in detail, we're going to solve this. Yeah, it's just Lagrangian. We're just plugging into Lagrangian and we're getting the work done. When you see a problem like this, there's nothing to be worried about. You just write a Lagrangian and you know 100% you're going to get the solution. It might be a little bit rocky, but 100% getting the solution. So let's get to work. Px plus Qy minus 5 lambda 5xy minus x squared times y squared minus 4. Derivative of L with respect to x, p minus lambda 5y minus 2x y squared equals to 0. Correct me if I'm wrong, but I hope I'm not messing this up. It would be multiple ways embarrassing. So just like this. 5x minus x squared to y squared is equal to 0. 2y, no y squared. Okay, and then obviously the constraint. Again, I sometimes like to write this constraint in the Lagrangian. Do not write this derivative in the Tucker because it's wrong. But in the Lagrangian, I sometimes just like to write it down. Just works for me. Anyway, now I'm just gonna get lambda out of here. So I was gonna write it here actually. Lambda is equal to P over 5y minus 2xy squared. Lambda is equal to Q. 5x minus x squared to y. Lambda is equal to lambda. I just copied that. Somebody wrote that, which I think makes perfect sense. I like it. So it's P 5y minus 2xy squared is equal to Q 5x x squared to y. Okay. So at this point, just multiply everything. And I get P times 5x minus x squared to y is equal to Q 5y minus 2xy squared. You look at this equation and it looks absolutely hideous. So I tried to make it work better. I see an x here, an x here. So I just factor it out and I get P x 5 minus x 2y is equal to Q. I see a y here, so I do the same. Y 5 2xy. Miraculous, out of a miracle, whatever, that's what I meant to say. it goes that this works. I can simplify this with this. And I get Px is equal to Qy. Over to so this is a little bit loosely speaking. I haven't actually paid attention to it in the grading, but you should consider it. Here, when you simplify, which is necessary to solve the problem, it's not wrong. You need to make sure you're not dividing by 0. Okay. So this case, if I wrote this, I am, I divided by 5 minus 2xy, okay? Which I assume is not 0. If you want it to be really formal and like would deal with somebody that's very, very strict, you would have to check that this is not 0, this doesn't give you a particular solution. Because imagine if you have a relationship and you're just dividing by 0, you're basically ruining it all. So that's what I was like computing mentally here a little bit. So if it's 0, just parentheses small here. If it's 0, it would mean that xy is equal to 5 over 2. So this would just mean that replacing in the constraint, I would get 5 times 5 over 2 minus 25 over 4. This is definitely not equal to 4. So it's not 0, okay? But it is important to sometimes check. Niels in the last, the professor from last math 2 would give problems after problems in which if you divide it by 0, you lost half the solutions. And eventually people realize, hey, I have to check this. I don't know if the current professor is going to do that, but be warned, like you're going to see when you do exams from last year that he's really onto that. Anyway, so this is my check to see if it's 0, but it's not 0, so it works. Anyway, this is your relationship. And now how you correctly did, you just said y is equal to px over q, and you replace in the budget constraint. Now, it is important to see the difference here. Why am I not leaving the result like this and saying, okay, this is the end, I'm done. This is whatever, x is equal to qy over p. This is my final answer, and I'm done. Because we did the same thing here, okay? We did the same thing here, where we just wrote xy is equal to this, so I'm done. Or x is equal to this, and I'm done. Okay? See, I'm just trying to show you that why you need an argument in this case in order to give me this solution. In this case, when you give me the argument and tell me, hey, the product is the only thing that matters, then I'm going to tell you, yeah, then you're fine. This is the final solution. But in this case, this is definitely not the final solution. But you see the difference, right? Like here, it's perfect to leave it like this. Xy is equal to this, or x is equal in terms of y. Here, it's a mistake. You lose half the points. So let's just get y, replace it in the budget constraint. And I get 5x times px over q minus x squared px q, everything squared, minus 4 is equal to 0. Replace it in the budget constraint. This procedure is pretty standard. Get one in terms of the other, replace in the budget constraint, and we work it out from there. What do we get? I'm going to multiply this whole thing by q squared. So you get 5px squared times q minus p squared x to the 4th minus 4q squared is equal to 0. Now, you do not know how to solve 4th order equations. I don't know how to do that. Nobody actually even knows. So you have to do a small trick here, which is just replace x squared with a u. Okay, this is the trick you have to do. You know quadratic equations, right? You just don't know 4th order equations. So the way you do it, this just becomes 5pu q minus p squared u squared minus 4q squared is equal to 0. Okay. Now I just like it to write it as a, I just like to have my thing with a plus. I'm bad with minuses, so I'm just gonna write it like this. This is just me. And this is the standard quadratic equation. So what do you do with this? You just let it rip. So delta, or I forgot how we called it. Another ABC rule, I think it is. I forgot how we called it. Okay, I write it with ABC rule. Okay. Yeah. So you get square root of what do you have here? 5pq, so that's 25, let's write it nicely. 5pq squared minus 4 times 4q squared times p squared. So my delta is equal to 25p squared q squared minus 16p squared q squared. So my delta is equal to square root of 9p squared q squared. So this is just 3pq. Okay. Awesome. Now I'm ready to just get my solutions out. Okay. So my u1, u2 is equal to 5pq plus minus, I messed this up. There's no square root here. But okay. Plus minus delta, so plus minus 3pq over 2a, which is 2p squared. So I get u1, 2 is equal to, and divided p, it's 5q plus minus 3q over 2p. So I get u1 is equal to, what's this? I'm so bad at this right now. 2q over 2p, so it's q over p. And then u2 is equal to, you just add them, 5 plus 3, that's 8. Sure, sometimes my brain just stops. 5q over 2p, that is 4q over p. Okay. Remember though that u2 is just equal to x squared. I mean, x squared is equal to u. So I'll have, sorry about that. Okay. So I'll just have x1 squared is equal to q over p. So I'll have x1 is equal to square root of q over p. And then x2 squared is equal to 4q over p. So x2 is just equal to 2 square root of q over p. And from here, obviously, you get y1 is equal to square root of qp. I think it was times pq. Yep. pq, which, if you do the square roots, it's just square root of p over q. I got root on this, doesn't matter. And then y2 is just 2 square root of qp times p over q. So there's 2 square root of p over q. Okay, and I'm done here. So yeah, this was the solution for the for point E. Point E was extremely mathematical in the sense that it had nothing to do with intuition. It was more just like write the Lagrangian, express one in terms of the other, plug it, and then plug it in the constraint, and then do the math. And I think on the other side, you have problem number D, which was purely drawing, purely just understanding how the graph looks like. So I think it was a decent mix. But yeah, I think realistic. I think problem D was actually pretty tricky, and I think the suggestion should have been a little bit stronger. But yeah, this was it. Yeah, if you have any questions, just let me know. But yeah, see, we finished in 1 hour and a half. So that means in the exam, you guys are going to finish this in 45 minutes, right?
Yeah, I have a question about this last one, right? So I took a different approach. Like I just solved the side constraint. Found like where it's yeah, where this is here, right? Where I found X, Y, like this is essentially the same, right? So I could build this as a side constraint and run. This is good. So I got like what I feel is the correct answer. I'm not sure if I have to do this.
So,
Yeah.
or yeah, something. So you can do that.
Yeah.
But something went wrong in your computation because you missed like X, Y is equal to 4 as a solution as well.
No, but I have it here. But
that's
I'm right. Because the X, Y is equal to 1 minimum.
Yeah, yeah, I forgot to replace it. It's completely right. But yeah,
Yeah, I wrote
no, like you can do this. It is more complicated and partially unnecessary, but yeah, you can do it. Like if this is your constraint and you basically just rewrote the constraint,
yeah, exactly.
which is fine.
Because then the Lagrangian is super easy. Right?
Yeah, that's fine.
I just get this. All right.
Yeah, but we have the two branch. This one for this and one for this.
Okay. Because I only chose this one.
Yeah, exactly. Which is a very educated guess.
Yeah. Okay. Okay. Cool. So if I wanted to get the full score for this one, I would include.
Yeah, you can do this exactly for this, which is fine. And then you have to do exactly this for this, right? Because
Yeah.
that's right.
Okay. All right. Thank you.
I can give them to you. I don't think anyone can. Let me just arrange them for you. Nobody asked them for them, and last time I threw them away, so I mean, just get them. Yeah, exactly. So just seriously?
I'll get that feature.
No, wait 1 second.